In this video, I'm going to be introducing the concept of related rates, but to do so, we want to do a quick review of implicit differentiation. So when we have an equation which is written implicitly, as this particular equation is, meaning that the x's and the y's are all kind of mixed up together, it is not explicitly written as y equals some function of x, then we have to find the derivative dy dx implicitly. And to do that, we use the chain rule. Okay, we use the chain rule to do implicit differentiation. So the way that works is we take the derivative of y to the fifth. Now, because we are finding dy dx, this implies that y is the dependent variable and that x is independent. So whenever we take the derivative of the dependent variable, we use the chain rule. So the derivative of y to the fifth would be 5y to the fourth. And then using the chain rule, we want to tack on a derivative of y with respect to x. The next term, y, the derivative of y would be 1. But because y is our dependent variable, we tack on a dy dx. That is the chain rule. Equals. Well, x is an independent variable, so we do not need to tack on a dy dx. 3 times 2 would be 6x squared. And then the derivative of 1 is 0. So that is how we take the derivative implicitly. Then to solve this for dy dx, we can factor out on the left-hand side, just a little bit of algebra left here. And so then dy dx will be equal to 6x squared over 5y to the fourth plus 1. So I have some videos on implicit differentiation. You can go back and you can review those for a little bit more in-depth analysis on that. All right. Now let's talk a little bit more about dependent versus independent variables. So when finding the derivative implicitly, it is important to understand which variable is acting as the dependent variable and which is acting as the independent variable. So as I showed you in the last problem, when we have dy dx, we know that whatever is upstairs here in the numerator is dependent, and whatever variable is down here, x, is independent. Number 2, we always use the chain rule when taking the derivatives of the dependent variable. That would be the variable in the numerator of dy dx, not the one in the denominator. So we looked at that. Given the Leibniz notation dq dp, we know that q is the dependent variable, as I just said, and p would be the independent variable. The dependent variable changes with respect to the independent variable. And that's how, from a word problem, you can often tell which one is which, because it tells you what is changing with respect to what. So let's take a look at this example. Given the implicit function, determine how the variable q is changing with respect to changes in p. So they're saying, how is the variable q changing with respect to changes in p? That is implying that we want to find dq dp. Okay? In other words, q is the dependent variable, p is the independent variable, not dp dq. No. All right. So that's the first thing that you need to assess when reading a problem is what is the dependent variable, what is the independent variable. All right, so once we know that, we can get rid of this. Once we know that, we know how to take the derivative implicitly. So we're taking the derivative of 3q. That would be 3. Q is the dependent variable. I'll highlight the dependent variables here. So we have to tack on dq dp. The derivative of 5p squared. P is the independent variable, so it's simply 10p equals Q, once again, is the dependent variable, so we have 4Q, chain rule, tacking on the dq dp, and then the derivative of minus 7p is minus 7. All right, from there, we just need to solve for dq dp, and so when we do that, we're going to end up with 10p plus 7 over 4q minus 3. So it's important to know what the dependent variable is and what the independent variable is when you're doing a related rate problem. So let's take a look at what related rates are all about. Related rates are all about changes over time. Changes over time. Everything changes over time. In business applications, many quantities change over time, such as revenue, profit, costs, quantity, price. Those sorts of things are changing with respect to time. In a related rate problem, the independent variable will always be time. Therefore, this is very important, all other variables will be dependent variables. So let's take a look at this. Now, this is the same equation that we just did, but we're going to be doing it a little bit differently. Determine how the variables P and Q are changing with respect to changes in time. So to find out, first of all, how P changes with respect to changes in time, that is implying that we want to find the change in P with respect to time. Then when we want to find changes in Q, that is implying that we want to find changes in Q with respect to time. So these are the two things that we need to find, dp dt and dq dt. So in this problem, P and Q are both dependent variables. P and Q, all of these variables are dependent. The independent variable isn't even stated in the equation. It is time. So let's find dp dt first. dp dt, so we're going to take the derivative of this with respect to time, implicitly, treating Q and P as dependent variables. So the derivative of 3Q would be 3. Now it's dependent, so we have to tack on dq dt. The derivative of 5p squared, P is dependent, so we're going to get 10p dp dt equals 2q squared. Q is dependent, so we would get 4q. Tack on the dq dt minus 7p. P is dependent, 7 dp dt, and then the derivative is 0. So this is the derivative with respect to time. Now, to find dq dt, it wouldn't be any different. We would do the exact same thing here. The only difference is to find dp dt, we're going to then solve for dpt. To find dq dt, we're going to solve for dqt once we do this. So dp dt, we want to solve for that. That would end up being dp dt. Let's see, I need the right pen here. dp dt is going to end up being 4q minus 3 over 10p plus 7 times dq dt. And I'll let you do the algebra to get to that point. We're simply solving this for the variable for dp dt, which is this. So it's just a little bit of algebra, which we've done many times. Now, solve for dq dt. I'll do that in red. Solve for dq dt. We simply need to solve this for dq dt, right? And so when we do that, it looks like dq dt will be 10p plus 7 divided by 4q minus 3 times dp dt. All right, so what we've done in this video is set the stage for actually doing a related rate problem. In the next video, I'm going to take the elements of what we did here and actually apply it to an application problem involving related rates.